Good morning. My name is Carlos Perozo. I work for Scalable Robotics. We're a partner of ABB. What I'm going to be showing you today is a demonstration of our product. This particular application is Putnam. A quick introduction of our Scalable with a 𝐀𝐁𝐁 company. What we do is to make it easier for anybody to program robot without the need of robot programming now or having CAM model available. So what I'm going to do, I'm going to show here. The system automatically scans a part before it completely. Most of what the model looks like. So you can see that the model is relatively detailed. The next step that I'm going to do is I'm going to start teaching. The idea is just, I'm a user and I want to be able to cut a hole in that gun. Okay, that's my goal. So what I'm going to do is I'm going to show you a feature. So what I'm going to do is the simply select the magic clip. Now notice what's important. It shows you here. But I'm also going to preview on the dome. There's a concept you see on the left and click in the projection hub. When I project, you can see that on the dome. You see this right here? It projects the actual point that I'm going to cut. I'm going to cut you a hole in that area. So I preview. If you like what you see, you say, okay. The next step is I generate all the path to be able to cut that dome. Normal to the surface cutting. Notice there's a complete dome surface. So that's why there's a lot of points. The next step is I need to modify the angles. You see, I'm changing virtue angle. You don't want to cut on an angle. You want to change the rear end to 2. And that's what I'm doing. The next step is I say verify. Verification is nothing more than can the robot make that motion. We're inside Robot Studio, which is a very accurate representation of the real robot. So what you're going to see here, if you run here, it's going to run on the robot. The next step is I just simply send it to the robot and the program is ready to run. I'm simply going to command the robot to go run that path. And there's the final path. You can zoom in there and see it's a very accurate positioning. So there the path automatically generated. In summary, I was able to teach the path how to cut a particular metal without the need to know robot programming or any CAD knowledge. I simply formally clicked and I told the robot where to go. Next, you're gonna walk over here and I'm gonna introduce you to the other gentlemen, which can give you more information about other applications for ABB. Let's come over here.
Hi, my name is Eric Putnam and I work for ABB Robotics. I set up this demo for the train show showing off the ABB GoFa robot with the iMotion camera-agnostic software. This system is picking up a cup out of a bin in this example, placing it to a fixed location, and then another camera is being used to find the barcode that's on the cup and stacking. The camera system finds the cup, passes that to another piece of the ABB software called automatic path planning to generate the most efficient path from the bin to the regrip stand with all of the SolidWorks data represented to prevent the camera and robot from ever colliding with the wall, core, table, and bits.
Hi, my name is 𝐀𝐁𝐁. I am from application engineer for ABB Automotive team. And here we have, hi, my name is Ravi Kandya from ABB Automotive team. And here we have like automotive lab. So I'm just going to explain each robot from the first display. So this is our SWOT instruction robot. So it is used for inspect because what we are doing in the looking is done. So we have a tar body of the 3D metal bodies, or we do this portion and feed it to do some inspection. So we'll go for the scope inspection. So what it does actually, it do the ultrasound sensor at the pool, and it will test the tar body on the sport thing here. It measures the quality in terms of like IMA goes here, how the scanning is passed through, all this information. And also we collect about information of outside. So by default, it's an Excel file, but you can export to any source. Mind that you need what you can use to the house. So nice work. This robot does. And we can go ahead to the second bar. So this is our line tracking robot. So what it does is it tracks the part on the AMR over there. Maybe this.
So much on this stuff.
So this is the vehicle is called as AMR, which is a fractional robot. So it can carry up to 1.5 tons of weight. And also about the skin platform. So right now it is doing a precision military there. So when the AMR is in position, it is going to send a signal to the robot for start doing the scanning. So what it does right now is scanning the spot inspect and recording all the codage informations on the PC. It's going through all the spots. So once the spot inspection is completed, the robot will tell the AMR to move to the next station. So soon it's going to start to the next station.
So yeah, that's a little
So there the AMR goes to the second station, and you can see it uses a visual servoing to detect the part. So it's actually like detecting the ABB Robotics logo, and it's going to do a rundown of the net on the part. So this is going to do a down as F. So all this happening in the Go. So the feature we use is a vision-based line tracking. The camera telling the robot like where to move and track the part. So it's going for the lifter down to the normal position. And it moves to the next station, which is the painting zone. So this is our GoFa cobot. It's certified for ethics for the explosive environments. This robot is used for the painting application, for potting applications, where the environment is like explosion. So here we are mimicking a painting by using a laser. So once it is working the painting, it tells the AMR like, okay, you can hold that to the next station. So it will do a immediate return replacement. And both match the first station, and it continues the same stuff as So all these robots and the air are connected to obviously robots system. They can integrate like any robots or code for that, and number of AMRs of the nervous system.
Don't take session.